just got done looking at using the keyboard to control the turtle in MicroWorlds, and want to take a look at what goes on in CodeSculptor. So I was looking through the docs and at control objects and keyboard controls, and saw this example here, this ball position control example. So let's run it and see what it does. So there's a ball, it starts out in the middle. If I press the up arrow key, it registers. Every time I do a key down press, it registers. If I hold the key down, it doesn't keep going, it just stops. So it's kind of cool, but it's not really. I would like it if, what I really want is if I keep it down, that it keeps moving as long as I have the key down, and then when I come up, it stops. So let's look at how this one works, and then we'll figure out how to do the other thing with having it move continuously until we put the key up. But for now, let's see what this one does. So this one, now see, notice, what I noticed right away is this one has a key down handler, but it doesn't have a key up handler. So that makes sense. So it's only registering the key down events. So remember when we were doing that echo example, we would see key down and key up. Here I see key down, but when I pick up the key, when I pick up my finger, it doesn't register any key up event. So so let's see, well, what does it, so we have our, we import our simple GUI, we set up our initial state, all these variables, right? We have two event handlers. We have the key down and we have a draw handler. And then we create the frame right here, and we register our event handlers, and we start everything off. Okay, so the draw handler just, does this, just draws a circle at whatever our position is with our radius. So the radius is 15. Our position starts at we divide the width by 2, and this int just makes sure that's an integer value. So, and do the same thing with the height. So we draw the circle at that position with this radius, with a line thickness of 2, and the line around the circle is red, and the circle itself is red. So it comes out looking all red. That makes sense. Okay, so that's the draw stuff. But then what happens when we say key down? So we have this thing here, if key equals. So remember in MicroWorlds we did a read char, right? And then we checked to see what that key equals. In CodeSculptor, we have this thing called a key map in the simple GUI module. And a key map is a cool thing. It's a kind of dictionary. So one way to think about it is it's kind of like a list, but instead of numbers in here to tell you like an index into the list, how you usually for a list you'd have like 0, 1, 2, 3 or so on. For a dictionary, you can stick in strings in here, and it'll find the key that goes with the string down, for example. So this will find, and this is awesome because then you don't have to worry about if you're running, in a Mac or in Windows or whatever. In MicroWorlds, these ASCII keys are different for the left and right arrow, but CodeSculptor takes care of that and converts it for you. If you're running off of a Windows machine or a Mac or whatever, it's and I don't know if I guess because it's written in JavaScript, so JavaScript probably takes care of all that, or helps at least with that translation of, the down arrow key is this one, the up arrow key is that one, and so on. But anyway, all you have to remember is if you want a down arrow key, if you want to compare something to the down arrow key and see if it is the down arrow key, you say simple GUI dot key map, and key map is in all caps, and there's this underscore, and then say down. So if the down key has been pressed, then what we're going to do is we're going to change position 1. And why position 1? Well, remember, this is position 0, that's the x coordinate, and position 1 is the y coordinate. So if we press the down key, it's only the y coordinate that we want to change, and we want to add to that y coordinate because the y coordinate gets bigger as we go down. So if we add to the y coordinate, that means we're moving down this way. Okay. For up, we subtract the velocity from the y coordinate. Okay. If we're moving right, we add the velocity to the x coordinate. Okay. Or we subtract. If we're going left, we subtract the velocity from the x coordinate. Okay. So that's why that does what it does. That kind of makes sense. But now let's say we want to have we want this, if we're pressing the down arrow key, we want it to keep doing that until we pick up the arrow key. All right. So let's make our velocity. Let's do what we did for velocity with the microworlds example. Let's make velocity be a list instead of a number. And we'll start out at 0, 0. And what we'll do is we'll say if we're pressing the down key, then the velocity is going to be, so if we want to go down, we're going 0 in the x direction, but we're going a positive 5, let's say, in the y direction. And I'm going to get rid of this position stuff. And if we're going up, then we want to change our velocity to 0 and negative 5. So up or down, we're changing the y coordinate, right? So down, we're changing the y coordinate in the positive direction. Up, we're changing the y coordinate in the negative direction because y gets smaller going up and y gets bigger going down. So if we're going to the right, that's x gets bigger as it goes to the right. So we're going to have positive values, a positive value for the x, but this is going to be 0 now because we're not changing the y. If we're going to the right, we're not going up or down, we're just going right here. And then let's do this for left, we're going to go negative, okay? And that's all we do for key down. And then what we can do is we can have an update. That says change the position. So position 0 is going to be position 0 plus velocity 0, and the same thing for position 1, right? So actually, a cleaner way to do this would be if we just said for I in range 2, we'll just let position I equal position I plus velocity I. Okay, and that's our update. So then before we draw, we'll make sure we update. Now the thing is, so that'll make our velocity stay the same as long as the key is down. We'll keep moving. What we want is we want to have a handler for key up that stops the ball when we put the key up. So let's draw that, and then we're going to have to register it, right? So let's say key up, key, and just when the key's up, we'll just set the velocity back to 0. Velocity equals 0, 0. So now when the velocity is 0, that means our update is going to have basically no effect, right? Because this velocity is going to be, we're just adding 0 to the x and the y both times, because this is 0, 0. So we're not changing the x or y as long as, once the key is up. So we got to make sure we register that, right? So let's copy this and paste it. And this is going to be our key up handler called key up. I'm going to copy that, paste, okay, and let's see how that works. Oh, it doesn't work at all. Okay, so let's see what's going on here. So what I want to happen is I'm holding down the key, but nothing's happening. So what I want to be happening is, since I'm holding the up arrow key, I should be going up. So let's see now. I did call update. So one way to kind of trace through and see what's going on is, well, there's pi step, but another thing we could do, another thing that programmers commonly do is, oh, you know what? I think I know what I did here. Velocity is a global, isn't it? So let's see. There we go. So as long as I'm holding down the key, it moves, and if I don't, so that old global, man, don't forget about that, like I just did. But this is a little bit better. So now we're getting more gamey type stuff. And actually, what I think I want to do is create a class that knows how to do this, and we're getting pretty close to where we can do something that's kind of like a game. But yeah, I think for the next video we'll incorporate all this into a class and put it in the same file with the ball stuff, so that we can have maybe like a predator ball or something that can go around. But for right now, I think the next video what we'll try to do is have a ball that we can navigate like this, and all the other balls kind of doing their bouncing around thing that they're doing for right now.